Hello, welcome back to Stunning Science. In our last video, we have discussed about the image formation in a plane mirror and we have proved object distance equals to image distance. Today, we'll be learning the number of image formation in a plane mirror. So there is an interesting formula about that. Let us see this formula. First, we are writing number of image formation, number of image formation in a plane mirror or plane mirrors. So here we'll be discussing two mirrors and we'll be bringing an object in between two mirrors, plane mirrors. Then we'll observe the number of images, right? So there is one interesting formula. This number of images n is equal to 360 degree divided by angle theta minus 1. This formula you need to apply to calculate the number of images formed by the plane mirrors when they are kept at certain angles, right? So for example, when two mirrors are perpendicular to each other, so this is plane mirror. So how many images would be formed if an object is placed symmetrically? What do you mean by symmetrically? So the same at equal distance from both the mirrors. So this is called symmetry line. Here an object is placed. So this distance and this distance are equal from both the mirrors M1 and M2. So this is called symmetrical position of the object. If it is placed symmetrically, the number of images formed is equal to 360 degree by theta. Theta is equal to 90 degree as they are placed at 90 degree, right? Perpendicular. So 90 degree minus 1, 4 minus 1 is equal to 3. So number of images formed is equal to 3 when two plane mirrors are placed at an angle of 90 degree with each other. If they are placed at an angle 60 degree, similarly, it should be n is equal to 360 divided by 60 minus 1. It should be 6 minus 1 is equal to 5. If it is, let's say, 30 degree, M1, M2, M1, M2. So n is equal to 360 minus 30 minus 1. It is equal to 12 minus 1 is equal to 11. So number of images would be formed 11. Can we prove it? So just take one example. Let's say two mirrors are placed at 90 degree. So is it the images are from 3? Is it really happening or not? So it is a completely geometrical concept. So we can prove. However, you can also do using pencil, compass, and you can have also two plane mirror strip and just join the two mirror strips and bring one object, let's say one small ball, one marble, or any object, and just increase or decrease the angle in between them, right? And there is another interesting thing I need to highlight. If the two plane mirrors are parallel to each other. What do you mean by that? If they are parallel to each other, then the angle between them is theta is equal to 0 degree, right? If the theta is equal to 0 degree, then n is equal to 360 divided by 0 minus 1. I am just leaving. Okay, so I am just leaving minus 1 part. So 1 by 0, we know it is infinite. So number of images would be formed, infinite number of images would be formed. So we can see lots of images, and it is very interesting. So you might have observed, or so there are many decorative LED light, or if you go to any science center, so even in some science centers, so you can see infinite well, okay, infinite tunnel, okay. So this tunnel actually goes long direction, right? It doesn't end. So the fundamental concept is that two plane mirrors are kept parallel to each other. So the number of images are infinite. So you can see it is endless tunnel or endless well or whatever the object is that. Let us try to explain the geometrical concept when two plane mirrors are placed at a 90-degree. So these are the two plane mirrors placed at 90-degree. Let's say an object is placed here, and let us draw a few couple of rays from the object, and it will be reflecting from the two mirror surface. It is M1 and M2. So this is the incident ray, and we know the image distance is equal. Now at the same distance, so the object is I, let's say. So image is I dashed. It is formed at the same distance behind the mirror M1. Now the interesting thing is that this I, this mirror, this image becomes the virtual object for mirror M2. Clear? Yeah, so that will come actually. So now thing is that this mirror, this object, and also there will be one incident ray for mirror M2. The object will be I, and this will be formed behind the mirror. So this is, I can write I dashed, I double dashed. Okay. So this distance, let's say this is this distance and this distance equal. Let's say this is x, also this is x, and let me draw using red pen. This is also x and this is also x. Okay. Now see, this is the image of I by M2. Now I'm just extending back this mirror. Why? Because this object, this virtual image, this image will be acting like a object, a virtual object for mirror M1. That is why we need to extend it back. See? So at the same distance, this is also x and this is also x. Here I2, I3 dashed. Okay. So now you can see, right? So this becomes the image for object I dash becomes the image of object I, and the object I is for M2 second mirror. The virtual image is I double dashed, and for this object it becomes an object with respect to mirror M1. So it will, I have extended back the mirror axis, so it will fall the object here, right? Now another important thing is that I need to also extend back this line. Now tell me why? Because this becomes an virtual object for this mirror M2. So this was the object, initial object, original object for M2, but now it is an image for I1, but this image also acts like a virtual object for mirror M2. That's why I need to extend it back. So again it will be like from, so I need to just, this is the image distance. So for as per the geometry, I can say this is also x. This is also x. Another interesting thing, so here number of image 1, here 2, and for it here 3, and for this with respect to this mirror, here it is also overlapping here, so 4. So total number of images produced 4, but our formula says 360 by 90 is equal to minus 1 is equal to 4 minus 1 is equal to 3. So but here actually it is producing 4. Then what is the conclusion? The conclusion is that here we are getting two images, 3 and 4, and they are overlapping each other. They are overlapping, or they are forming at the same point. They are forming at the same point. That is why we are considering only one image. So 3 and 4 would become only one image. Always remember this. So hence this is only one image. So 1 plus 1 plus 1. So total becomes 3 image. So this is 2 means that so this is the image number 1, image number 2, and image number 3. So 1 plus 1 plus 1 is equal to 3. Now if you want to verify, so just take a pencil, compass and thing, and just if you make a circle, so exactly it will be a perfect circle. So again it can be verified that all distances are equal. So our conclusion is that if an object is placed in between two mirrors, that mirrors are placed at an angle 90 degree and the object is placed symmetrically, okay, at the same distance from the two mirrors, then the number of images will be formed 3, and all the images would be produced at the same distance. I mean the object distance and the image distance for each case would be same. So I think it is clear, right? So yeah, this is very important concept, and practice it, and let us verify, and let us also calculate the more number of for variation of theta, for example 10 degree, 20 degree, 35 and so on. Let us try, and let me know in the comment space. And yeah, for example, if it is something decimal, for example 4.8, then how many images you can consider? Only 4. So point number we cannot consider in images, because we cannot get fractional part, right, small part, right? We can get only the whole part of the object, right, as an image, right? So 4. So I hope you enjoyed this session. More stunning concepts are coming, and more concepts on lights are coming, and for also going for other chapters. So till that, stay tuned and take care. Bye bye.